Uh, Thank you for joining. Sorry if I'm a little bit late. I was having problems with Zoom. So today we're gonna talk about a bunch of new updates that we're gonna add to Calico 331. If you are not familiar with the previous ones, there is another Calico community meeting, which we did like a month ago. There's a lot of things in there. We also have a community member, Stefan, who is going to talk about his own Calico journey and experience. They're having a very cool sort of setup between multiple countries, and they're doing a lot of cool things with Calico and Kubernetes. So we would like to know about these sort of things. If you're using Calico and you want to share your story with us, please let us know. There is this community meeting that you can come in and talk about stuff. And I'm also here with my coworker, Michael, who is hopefully going to talk about some engineering things, but it's nothing is set. So he's hearing it just right now, but we'll get him to talk. Anyway, so let's get started. By the way, if you are watching this on LinkedIn or YouTube, just and you have questions, send your questions in. Hopefully somebody here knows the answer and will tell you. If not, there's always our Slack channel. A lot of engineers are always in there, and they would help you to get your thing started. So in terms of new things that we are adding to Calico, we had a lot of conversation about people creating resources and not being able to validate them. It's not every resource, but let me just share my screen so you know what I'm talking about. Oh, having again Zoom problems. All right, so the idea is sometimes when you create some resources, you're not able to verify them. Now, what resources I'm talking about? These are usually like policies or like BGP peers, these sort of things. So when you create these like Calico resources, there are no way to verify it before applying it. So we got a new hire. It's an AI. I heard if I use this word, we're gonna get monetized. So it's an AI, and it did a PR. It didn't on its own, so we're not there yet. But one of our engineers helped it to create a validate command in Calicoctl. So if you have any sort of Calico resources after 331, you can use Calicoctl and figure out if that resource is valid or not. And it's pretty simple. You just do Calicoctl validate -f, similar to how you apply it. And it would tell you, is it all right? Is it not? And hopefully it gives you some interesting insight. Now, if you are into AI talking sort of things, I would highly recommend like following this thread. There are a bunch of cool things happening between humans and AI. Anyway, so the next one is this one that I want to talk about. For 331, we're doing a lot of things in order to deprecate sort of old codes that we had to like add in order to get Kubernetes to do things that we wanted. Now, Kubernetes has come a long way. And there's a lot of these things that we sort of created, added in like bits and pieces here and there. Now, with that, we created sort of like a compatibility layer. And we were like, all right, we have our version 1, and we're going to create a version 3. But for some of the stuff, we're going to still use the version 1. Now, with 331, we're getting to the point to like getting rid of most of the V1 or version 1 APIs that we used to offer. We're also going to get rid of a Calico API server. So everything that used to be like sort of conversion between these two versions is going to be only on V3. Now, that being said, as a user, nothing changes for you. You still do everything that you want in the same way. It's just we're in the background doing the heavy lifting to, do everything for you. And you can use V3 CRDs and those sort of things directly, and you won't need the API server. And the next one is actually, let me go to BERT before I go to last one that I can demo. So there was a problem, if I understand it correctly, that our network was unavailable if Felix was not ready. There was a readiness probe that would make Calico node sort of behave a little bit awkwardly. So with this PR, it's going to be fixed. And now if your BERT instance is not up, it shouldn't enforce Calico to not be up as well. So the container health is going to be okay if one of the components that are not that critical for that container is not up. That being said, I'm going to show you a quick demo and turn to Stepan to share his story with us. Now, if you know Calico 330, we added a bunch of things. One of them was the ability to see all the flows. So this came in a package with something called Whisker and Goldwing. So Goldwing would take these flows that you see, and Whisker will show them to you. Now, in order to get this, all you need is to upgrade to Calico 330 and do a port forward. That's about it. Now, Whisker, in terms of observability tool, has something different that others don't. And that would be, why would you use Whisker? And it's this policy row. So this policy row is a hierarchy of what decisions are derived from all the policies that you have written. So it would tell you what are the policies in your cluster, how they would behave in for this particular packet or flow, and what is the verdict. Now, I don't know about you, but I'm not a great JSON parser. So that was one of the feedbacks that we got in KubeConf. So is it possible to make this better or nicer or readable? And we added a new. So with 331, we added a new way to reading this chunk of JSON, and it's going to be something like this. Let me just. All right, 30 seconds. Still doing things. Are we having a live demo moment? Oh, things are running. Okay, we're having live demo moment. So we're gonna go to this part, which shows the actual thing that happens. So instead of that JSON, you would get these columns for each policies that you have. And it would tell you two information. One is enforced policy. Enforced policy is what is actually happening. So it could be allow, it could be deny, but it's what is being enforced. There's also something called pending policy. Pending policy is a different behavior, and it's only different if you have stage network policy in. So it would tell you for this flow that you already allowing or denying, because of this stage network policy, this might happen. And you from there, you could make a judgment sort of call and say, well, my stage network policy is ready, so I'm gonna push it to an actual policy so it will be enforced or not. With that, I'm gonna add host level sort of things to Stefan so he could talk about his own things. So Stefan, if you could please introduce yourself and let us know what's gonna
Yeah,
be.
sure.
Yeah.
Well, good evening, everyone. I'm Esteban. I'm from Argentina. I am a student at the National University here in Tierra del Fuego. It's a brand new university. And well, my team and I, we don't have many funds, so we built a cloud with our own servers. We got them like, you know, one of the members of the team got it from his dad. His father was a data center administrator, so and the other member just bought a server. We thought that we couldn't learn to do stuff with the cloud if we had to pay third parties, right? It was going to be a long learning curve and a super high one. So we took the chance and we decided to get our own servers. And then the next thing was trying to connect them together. We started with just one server, and it was just one computer at one of the members' house. The problem is that it wasn't a server, so it caught fire. It literally caught fire. So when we started getting serious with the cloud, we figured we need resources, but we don't have data center resources, so we needed to be as low end as possible. So the initial prototype was actually trying to run a Kubernetes cloud inside virtual machines. But as we all know, that subject has been touched a lot in the sphere, and there's limitations. So having a cloud like Minikube or K3s can work for a prototype or a test, but when you want to use things like Calico or sometimes, for example, storage backends, they don't work with Minikube, right? So the first thing we did was trying to find the way to virtualize an actual cloud, like not a test cloud, but an actual cloud. And we encountered a lot of troubles because of all the patches and workarounds made for actually having one just little cloud in a container. So the first thing we did was we made actual Kubernetes cloud nodes work inside LXC containers. And I'm saying containers because they were not VMs, they were actual containers. So we had to do some workarounds initially, and from the first day, we chose Calico because it had a lot of advantages from day one compared to the others. And one of them was how easy it was to set it up. So after a few iterations and getting new servers after that one caught fire, we had another problem. One of the members of the team is behind a CG NAT. So being poor as we were, we can be getting expensive internet services. So what we did is we set up a VPN, and with the help of OpenBS and some other technologies, we were able to actually make a network within this weird environment, right? Where one of the servers cannot get incoming connections, the other is in the UK. So we started, if I can share the screen, just give me a second. I don't even know how. I don't use Zoom much, so I apologize.
There should be a share
sharing.
button.
It doesn't get any easier with time.
Yeah, I skipped it during the pandemic, so now I'm pretty much new to it. Okay, so if you're seeing my screen, this is a small document we made to summarize our process. So this is the part where we were able to have 2 servers and then 1 VPS in the front. This VPS was our network router for the cloud, and we hit bottlenecks, lots of them, because we were just using computers at our houses and trying to route big chunks of data and keeping the cloud up, right? And when it gets to time to leave configurations and deadlocks and all the things that should work in the cloud, they are expected to have very low latency. So the first thing we fought with was latency. We had to configure everything with higher resistance to latency. We had 10 to 20 seconds resistance in the configuration, we will allow it. And then, well, we started fielding with the network configurations using open source and canonical solutions. That was one of the motivations we had. We didn't want to get bottlenecked on money by fixing things by just paying and then not being able to sustain it. So we try to use always canonical and open source solutions. That's also why we came to Calico. And we don't regret, really. And another premise we had, that was the hardest one to fulfill, is to be IPv6, purely IPv6. We don't use IPv4 for anything at all. Within the cloud nodes, within the containers, the only thing we use IPv4 for is to give internet to the containers. So why we did this is because we thought that firewalling the traffic was going to have a high cost on resources, right? So we chose to sandbox the environment by making it impossible to produce IPv4 packets within the cloud, and that's it. So by doing this, we didn't need to firewall or use policies, anything, because if the local DNS server cannot resolve the domain, then that's it. There's no way to attack, and it pretty much worked. We ran a lot of tests on security with this, and it worked. And well, we use Open vSwitch. This is
So I'm assuming everything networking is done with Calico in your Kubernetes part, in your container sort of CRI. You're on mute. You're on mute. Okay.
I think that's it.
You got it. We can't hear you.
No, you,
We cannot hear you anymore.
yeah, you unmuted and then remuted. Esteban,
You're
you're
muted.
still muted.
Maybe close the share and yeah. Now you should be able to
You can hear me now? Yeah,
Yes.
You got it.
I'm using press to speak, so while pressing the space in some windows, things break. But basically, what we did, we try to be cost effective. We try to find bottlenecks, and using this technology, we use Calico all the time. We try to not use anything apart from the basic parts like Calico, Open vSwitch, and Linux. That's it. And we got through a lot of issues while trying to be IPv6 native because we found out that most of the products don't have pure IPv6 testing. They pretty much rely on simulations of it or like dual stack setups. And that's a no-no for us because we really didn't want to commit any resource to firewalling on that subject. And the Jules kernel module was the biggest, the one that most helped the process because we fixed the biggest issue we had, which was giving internet to containers while them being purely IPv6. So once that worked, it was of a lot of help, but then we started testing and throwing things into our cloud, right? Like, if I can share the screen again, let's see. So some of the things we made work, we got working inside our cloud. Remember, this is pure IPv6, so it may look like default or common, but to us it was a lot. So one of the things I started testing was remote desktoping, like having a container and connecting to it using RDP, which is a Windows standard protocol, remote desktop, right? So not VNC, but RDP. We got it working, but there's a design limitation in the cloud. So there should be running just one process on every container, and we were running an entire OS here, so it didn't like it. It works, but it kind of breaks. It's not highly recommended. Next was Kubernetes dashboard because we were just doing everything using commands and the terminal. So we were very happy when we got this working in our cloud. And then comes Elasticsearch. Elasticsearch was one of the biggest parts of our setup because we needed to summarize all the logs in our containers. When we got this working, we started just throwing things into the cloud, and we didn't have a way to debug it or follow the processes. We were just blindly launching things and trying to catch the errors within a lot of logs spread all over. So we set up Elasticsearch and Logstash, and we got to put all the logs together in one instance of Elasticsearch. And then later on, like recently, very recently, we got playing with Goldmain and its API, and we built a little app that pulls all the flows and injects them into Elasticsearch. I've been sharing some screenshots of that with you. So my concern was we weren't able to actually visualize the flows before you made Goldmain. It was a very big concern to me because I was getting some bottlenecks on the storage part because we have like really low bandwidth on our servers. So it's residential internet, right? So our upload speed is really reduced. And sometimes it would just don't work. And I didn't know how to troubleshoot it besides using the common tools like Wireshark, right? But there's a lot of packets, there's a lot of IPs, there's a lot of containers, there's a lot of network interfaces to look at, and they change every time the container restarts, and it was crazy. So when we got Goldmain, it was like the missing link to us. And then, well, the dashboards are part of the cloud, so we're poor, right? We can pay it, we can afford it. So we just we sit down and debit. and we developed a little app. We got the metrics into our Elasticsearch, and with the help of AI, this is the first time we're actually using anything related to AI in our cloud. We got
just to let you know, you did a lot of work, which is amazing, but you sort of did more than you could, like you should have, because there's a Calico cloud free, which
yes,
would
yes.
actually do everything that you have done, but with like clicks.
I was about to use that, but then the problem we have is that since we self-host the servers, we got a lot of downtime. We got a lot of times when servers go offline, so we can't have the servers sending traffic towards a third party to save the logs, right? If we wanted to send you our flows traffic, whenever my server goes down, it starts collecting a local cache of those logs, and then when it gets back on, when it gets back online, it's going to produce a high use of bandwidth on our side to upload those. So we needed a local, a totally, fully locally deployed solution. That's why we deployed Elastic locally. And we deployed Goldmain, and then we started injecting our own flows in an index, and with the help of AI, we started making some dashboards which are like, they're ratchet. I gotta be honest. I don't really know about graphics and metrics. I'm more of a development person. So, but AI is helping a lot with it. Well, another thing we set up was Jupyter notebooks, and you gotta consider like everything we set up in our cloud, like Elasticsearch was a big trouble. And Jupyter notebooks, they are tested and used in IPv4 environments. So some of the things worked like straightforward in IPv6 and some didn't. And we also are using the Nginx service mesh, the Nginx ingress controller. We chose not to use the one offered by Kubernetes team, which is just a Kubernetes controller, because we wanted to keep the canonical definitions for virtual server, ingress, and those kind of things. We believe that those definitions and CRDs and that logic around the service mesh belongs to Nginx Inc. Like they kind of made it, right? Like they are the ones who started with it. They own kind of the thing. Everyone uses Nginx now in a different way, but their deployment around the ingress controller is pretty nice. It's got some issues, especially for IPv6 natively, but we got around with it pretty much pretty well. Now we know Calico has a new gateway ingress controller. I think it's called like that, and we want to test it for sure. But I think that, for example, when we want to launch new stuff in our cloud, we try to see how compatible it is with the things that already exist. And most of the things actually don't comply with the Nginx Inc. standards because everyone's using the Kubernetes one. We think that's wrong, but we will see. Time will tell. And the next thing we want to deploy, which is very it's not going to be easy, is the web IDE called Eclipse Che. I don't know if you know it, but there's a new thing came out from Google called Project IDX, and it's pretty much based on it. It's a web IDE, basically. Red Hat has another instance of it running. It's called Dev Spaces, I think. I am an Eclipse committer, and I committed some code to that project, to the Eclipse project, and it's pretty awesome. But they only create ingresses. They only create Nginx ingresses. So they expect to be hosted by Kubernetes ingresses, like not even the Nginx ones. So that's what we got to fix. This is one of the first times we actually got to sit down and make code and extend an application, own code to implement something, because we can't be patching the ingresses. This is a very complex application. The web IDE, it's got a lot of parts, so we can't be patching ourselves around it all the time because it produces new objects constantly inside the cloud, and every little service has its own subdomain inside that cloud. So it's not going to be easy, but we like the challenge. Well,
Yeah.
Jupyter Labs, we got Jupyter Labs working pretty well. We got the GPU working pretty well too. Well, we got some, well, afterwards, when we saw Calico could take it, we started using the Rucksack storage controller, which offers like a clone of S3, Amazon S3 storage services, like the buckets. So we got buckets in our own cloud. This is pretty awesome because it allows us to use the S3 libraries for Python and other clients to just connect to our own infrastructure as if it was Amazon. So it saved us like so much code. It's unbelievable. So we just use them, right? We can use them, for example, in Elasticsearch. It's got a lot of pipeline tools to save all content into buckets. So we were just using our own buckets. And fortunately, we got Cloudflare's help because we didn't want to expose our server's IPs. So we use a free tier of Cloudflare where they will proxy using a little application you set up in the servers called Cloudflare D. It's a daemon that allows us to connect both servers, and it will do the DNS routing depending on which country you are connecting from. It will choose the right server, and that's amazing. That's really what we needed, and it's free. I mean, we're using the free part, which is like this, but that's all we needed because that was our motivation, trying to be as free, open source, and canonical as possible, and always pure IPv6. That's non-negotiable. So we got this far. We're not gonna stop. We keep on coding. The team is called the Tug Nerds. You can check the website. It's pretty lame. It's called tugnerds.com. And it's just a scaffold because it doesn't show anything that we're seeing here. It's not there. This is just an explanation of the infrastructure we're building. And one of the things we're building on it is a login system based on crypto wallets. So basically, we don't like users and passwords. So we wanted to make a backend that can track an NFT collection, which are non-fungible tokens in a blockchain. So you could log into a service like a cloud service by just holding an NFT token in a wallet, right? But this is more like, this is not crypto-based. This is more like hash-based login system. It's not like entirely based on crypto. It's got nothing to do with crypto, but more with the technology. So just a second, sorry.
All right. So
I got visits. So thank you all for your time. This is a great project. We got really, really far. We didn't think we would get this far without spending any money, and we did. And that helped us because we were able to put more RAM in our services, in our servers, more disks, better CPUs, and this is being affording us all the time we needed to actually learn how to use these things, all these new technologies. For example, one of the members of the team is a developer. He was pure front-end developer, and within a year, he became a full cloud-native developer. And now he's making new things now. He didn't stop there, but if we had to pay Amazon for their servers or Google or Microsoft, right, just to sit down and test and learn, we will be so bankrupt right now. And we chose an approach that led us to having our own servers. And we're now thinking on getting Starlink connections to our servers so we don't go offline, or we're really getting new ideas and not thinking much about the money, which is great because sometimes it's not widely available, you know. And thank you all for your time.
I just have one question. I understand you guys run on a budget, but are you actually running Calico eBPF on 2 nodes with 200 pods?
Yeah.
Like, Is the stat that you provided to us, is that actually correct?
Yeah,
Okay, that is impressive. Thank you.
maybe more than 200 actually. I would need to check the number because that changes every day. I was up all night, pretty much fixing things because one of the nodes went offline for a few days. The ISP, the internet service in UK, in the small town in UK that has that server, went down for 3 days
I see.
for schedule maintenance, right? So we had to wait, and surprisingly, when it came back online, everything well.
Okay.
And I can't explain the feeling you get when that happens after so many months of fixing things and changing configurations and trying to find that. We reached that point, and we didn't want to come out to the market with a service or an offering if we weren't really able to sustain our own infrastructure. It was going to be easy to just run away to Amazon and tell them, okay, host this for me, please, because mine is going down every day. So we're reaching a stability point, and we got around 200 cores, 500 gigs of RAM between the two servers. We don't have a lot of bandwidth, but it's enough for us to work. Yeah.
Right. So we're now a little bit short on time. I just want to thank you for all the things that you're done with Calico, and keep on hacking. Thank everybody who joined, who's watching it awkwardly.
Let me just say, yeah, this is awesome. You guys made a guerrilla cloud. So yeah, respect.
Thank you. Yeah, if anyone has any question, I'm up to it. You know, my English is not that good because I'm actually self-taught, so I didn't attend the classes, and that this is what you get.
But it's perfect. Don't worry about it. My English is not good either. Doesn't matter. We saw the technology part and we all understood it. That's the part that matters
That's great.
to us. Anyway, so thank you for joining. This was our September community meeting. Thank you, Esteban, for sharing your great story.
It was a pleasure.
You guys can find us on Slack, GitHub, LinkedIn, other places. We're always in the shadows, so if you need us, we'll help you. Take care, everybody. Bye.
Bye.
Thank you. Thank you. Bye.